All right, so today we're actually going to start solving systems of equations with elimination. Remember, elimination is like where you get rid of something. So for example, if I have 2, let's try that again. If I have 2 and -2, or a +2, -2, those two would have a value of 0. So really it's about getting a value of 0. And remember, a 0 is very much elimination. So let's see what we have. So the coefficients are additive inverses. So if we add the equations, our goal here is to cancel a variable. So if we look at the example here on the right, plus 5y minus 5y, that is going to cause us to be able to cancel. So now we can actually add, like a giant addition problem, 2x plus 6x, which would give us 8x. And then we have 17 minus 9, which would give us 8. So from here, we'll solve for the remaining variable. And then once we've done that, we're going to substitute that back in. So in this case, I'm going to divide by 8. So x has a value of 1. So we're going to substitute back into the original equation and then solve for other variable. So for example, you can use the first or second, it doesn't matter. I'm going to use the first one. So I'm going to substitute a 1 for x and then solve for y. So this would be 2 plus 5y equals 17 minus 2. So 5y equals 15. Divide by 5. So y has a value of 3. So then our solution in this case would be 1, 3. And of course, we can substitute that back in, we can graph, we can do all sorts of things in order to determine if it's a correct solution or not. Let's try some other ones. All right, so our first step is to add the 2. If you notice, we have a positive 3x and a negative 3x, so that's going to give us a value of 0. So I can add 2y plus 4y, which is 6y. And then 7 plus 5 is 12. I'm going to solve for y by dividing by 6 on both sides. So y equals 2, which is our first step of the process. So now I'm going to take an equation. Again, it doesn't matter. I, out of habit, always use the first one. But if I have negatives, I avoid it. You know, it just depends on your preference. So here we have 3x plus 2 times 2 equals 7. So 3x plus 4 equals 7 minus 4. So 3x equals 3. I divide by 3, so x equals 1. So our solutions are x equals 1, y equals 2, or 1, 2. This is your password for your assignment tomorrow, so make sure you write this password down. All right, now here's our next example. Excuse me. So I'm going to go ahead and add the 2. If you notice, the x's are opposites of each other, so they cancel out. So remember, when you have just a variable, that's like having a 1 in front of it. So this is 1y plus 3y, which is 4y, equals 8. I divide by 4, so y equals 2. So now I know y equals 2. I'm going to use the second equation this time just because I noticed that x is negative and so on and so forth. So x plus 3 times 2 equals 4. So x plus, sorry about that. X plus 6 equals 4. Subtract 6. So x equals -2. So these are our 2 points. So we have -2, 2 as our solution. So again, it's all about eliminating a variable. All right, here's another. We're still, notice there's a bunch of negatives here, so always be careful with those integers. So I noticed that the y's are opposite inverses of each other, or opposites of each other, I guess I should say. So this is going to have a value of 0. So just to kind of show you, if we have -3x plus a -4x, that's going to be a -7x. Plus 0 equals 7. And I'm just showing you the plus 0 to show you that it just doesn't have any value. So now I'm going to divide by -7, divide by -7, x equals -1. Now that I know x is -1, I can go and solve. Again, I'm going to use this second one. So -4 times -1 plus 5y equals 14. So this becomes 4 plus 5y equals 14. Subtract 4. So 5y equals 10. Look at this. So then if we're going to write it as an ordered pair, this would be our solution. Now I want to talk about the fact that this process works every single time, the elimination. We're actually going to elevate elimination a little bit more tomorrow, but elimination I feel like is quicker than even graphing sometimes because you have to write it down, you have to put it in Desmos, you have to find the point of intersection and all that. So just to let you know that this one does work every single time.